When installing isolated ground circuits, you'll find there are two separate grounding paths. Firstly, there's the equipment ground, which is the ground terminal. This connects the metal parts of the equipment to the electrical system, which is crucial for protecting against electrical shocks. Secondly, you have the grounding circuit conductor, which is the outlet ground. This connects the metal yoke and the cover of the outlet to the electrical system, and its primary purpose is to provide a return path for fault currents. When it comes to using Romex in isolated ground circuits, especially in commercial applications where it's permitted, you should opt for a 12/3 with ground cable. The additional conductor in this cable configuration provides the dedicated path that the grounding circuit needs to function correctly. As for looping the outlet grounding conductors, yes, it is permissible. This can be quite beneficial if the intention is to provide flexibility in terms of equipment placement, allowing the equipment to be moved from one side of a room to another. This approach allows the equipment to be plugged into any outlet in the circuit without the need for separate ground wire. The installation process involves a few key steps. 1. Install the 12/3 with ground Romex cable from the electrical panel to the desired outlet locations. 2. Terminate the equipment ground conductor to the green or bare wire and the equipment's grounding terminal. 3. Terminate the grounding circuit conductor to the green screw or terminal on the outlet's yoke assembly. 4. Loop out the grounding circuit conductors at each outlet if you're aiming for that added flexibility. 5. Connect the black and white conductors to the appropriate terminals on the outlet. Always ensure that the circuit breaker or fuse for the isolated ground circuit is properly labeled to avoid any confusion. Never connect the grounding circuit conductor to the neutral conductor. It's a cardinal rule, and adherence to all applicable electrical codes and standards is non-negotiable. Let's dig a little deeper into the technical aspects. The equipment ground, sometimes referred to as the safety ground, is there to protect people from electric shock. It creates a low impedance path for fault current to flow back to the source, causing the overcurrent protection device, such as a circuit breaker or fuse, to trip and de-energize the circuit. This is essential to prevent dangerous voltage from being present in the metal enclosures of electrical equipment. The grounding circuit conductor, on the other hand, provides a dedicated path for fault current that is separate from the equipment ground. This is especially important in sensitive electronic equipment, where even small amounts of ground noise can cause problems. By isolating the ground for these circuits, the noise can be minimized, resulting in improved performance and reliability. When using Romex cable, it is critical to select the correct size for the intended load. The 12 American wire gauge wire is commonly used for 20 amp circuits, but it's important to verify that this size is adequate for the specific application. Consult the National Electrical Code, specifically Table 310.15b16, to determine the ampacity of conductors based on their insulation type and installation conditions. When terminating the conductors at the outlet, make sure that the connections are tight and secure. Loose connections can cause heat buildup, which can lead to a fire. Use a torque screwdriver to tighten the screws to the manufacturer's specified torque value. When looping the grounding circuit conductors, make sure that the loops are neat and orderly. This will make it easier to troubleshoot the circuit in the future. Also, be sure to use approved wire connectors to make the connections. Wire connectors are designed to provide a secure and reliable connection, and they are much safer than simply twisting the wires together. When labeling the circuit breaker or fuse for the isolated ground circuit, be sure to use clear and concise language. For example, you could label it isolated ground circuit sensitive equipment. This will help prevent someone from accidentally connecting a non-isolated ground circuit to the isolated ground circuit, which could defeat its purpose. The National Electrical Code, or NEC, provides detailed requirements for grounding and bonding electrical systems. It is important to be familiar with these requirements to ensure that the electrical system is safe and compliant. Article 250 of the NEC covers grounding and bonding. This article provides requirements for grounding electrode systems, equipment grounding conductors, and bonding jumpers. When installing isolated ground circuits, it is important to pay close attention to the requirements in Article 250. For example, Section 250.96 requires that all metal parts of electrical equipment that are likely to become energized be bonded together to form a low-impedance ground path. This includes the metal enclosures of equipment, metal conduit, and metal boxes. In addition to the NEC, there may be local electrical codes that apply to the installation. It is important to check with the local authority having jurisdiction, or OIJ, to determine what codes are in effect. The AHJ may have additional requirements for isolated ground circuits. For example, the AHJ may require that the isolated ground circuit be tested to verify that it is functioning properly. Testing can be performed using a ground impedance tester. This tester measures the impedance of the ground path, and it can be used to identify any problems with the grounding system. When selecting equipment for use in an isolated ground circuit, it is important to choose equipment that is designed for this type of application. Some equipment may have built-in filters or other features that help to reduce ground noise. These features can improve the performance and reliability of the equipment. It is also important to choose equipment that is compatible with the voltage and current requirements of the circuit. Using the wrong equipment can damage the equipment or create a safety hazard. When troubleshooting an isolated ground circuit, it is important to follow a systematic approach. Firstly, check the circuit breaker or fuse to make sure that it is not tripped. Secondly, check the wiring to make sure that there are no loose connections or damaged wires. Thirdly, check the equipment to make sure that it is functioning properly. If you are unable to find the problem, it may be necessary to call a qualified electrician. An electrician has the training and experience to diagnose and repair electrical problems safely and effectively. When working on electrical circuits, it is important to take safety precautions to protect yourself from electric shock. Always turn off the power to the circuit before working on it. Use insulated tools and wear rubber gloves. Never work on electrical circuits in wet conditions. By following these safety precautions, you can reduce the risk of electric shock. In summary, isolated ground circuits are used to reduce ground noise in sensitive electronic equipment. When installing these circuits, it is important to use the correct wiring, terminate the conductors properly, and follow all applicable electrical codes and standards. By following these guidelines, you can ensure that the isolated ground circuit is safe and effective. Remember to consult the NEC for detailed requirements and to check with the local AHA for any additional requirements. When in doubt, consult a qualified electrician. One additional point to consider is the type of outlet used for isolated ground circuits. These outlets are typically identified by an orange color and a triangle symbol. The orange color helps to easily identify the outlet as an isolated ground outlet. The triangle symbol indicates that the outlet is designed for use with sensitive electronic equipment. When installing an isolated ground outlet, make sure that it is properly labeled. This will help prevent someone from accidentally plugging a non-isolated ground device into the outlet. This consideration can help to maintain the integrity of the isolated ground system. Keep in mind that isolated ground circuits are not a substitute for proper grounding. All electrical equipment should be properly grounded to protect against electric shock. Isolated ground circuits are simply an additional measure to reduce ground noise in sensitive electronic equipment. When installing an electrical system, it is important to consider all of the factors that can affect safety and performance. This includes the type of equipment being used, the wiring methods, and the grounding system. By carefully considering these factors, you can design and install an electrical system that is safe, reliable, and efficient. Never underestimate the importance of proper grounding. Grounding is a critical safety feature that protects people and equipment from electric shock and fire. A properly grounded electrical system provides a low impedance path for fault current to flow back to the source, causing the overcurrent protection device to trip and de-energize the circuit. This prevents dangerous voltage from being present on the metal enclosures of electrical equipment. In addition to safety, proper grounding can also improve the performance of electrical equipment. Grounding can reduce ground noise, which can interfere with the operation of sensitive electronic equipment. By reducing ground noise, grounding can improve the reliability and accuracy of electronic equipment. When installing a grounding system, it is important to follow all applicable electrical codes and standards. The NEC provides detailed requirements for grounding electrode systems, equipment grounding conductors, and bonding jumpers. It is important to be familiar with these requirements to ensure that the grounding system is safe and effective. Also consider that the size of the grounding conductors is determined by the size of the overcurrent protection device. The NEC provides tables that specify the minimum size of grounding conductors based on the size of the overcurrent protection device. It is important to use the correct size grounding conductors to ensure that the grounding system can safely carry fault current. When making connections in the grounding system, use approved connectors and methods. The connections should be tight and secure to ensure that the grounding path is continuous. Avoid making loose or corroded connections, as these can increase the impedance of the grounding path and reduce its effectiveness. Regularly inspect the grounding system to ensure that it is in good condition. Check for loose connections, corroded conductors, and damaged equipment. If any problems are found, repair them immediately. A properly maintained grounding system is essential for safety and performance. Never disconnect or remove the grounding conductors. The grounding conductors are an essential part of the safety system and should never be removed or disconnected. Doing so could create a dangerous situation that could result in electric shock or fire. Remember that grounding is not a substitute for other safety precautions. Always turn off the power to the circuit before working on it. Use insulated tools and wear rubber gloves. Never work on electrical circuits in wet conditions. By following these safety precautions, you can reduce the risk of electric shock even with a properly grounded system. Consider the specific needs of the equipment being powered when designing the grounding system. Sensitive electronic equipment may require a dedicated isolated ground circuit to minimize ground noise. Other equipment may require special grounding methods to protect against lightning strikes or other electrical disturbances. Tailoring the grounding system to the specific needs of the equipment can improve its performance and reliability. Grounding systems play a vital role in maintaining the safety and functionality of electrical systems. Adhering to the established guidelines and best practices ensures that these systems effectively protect people and equipment from potential hazard. Always remember to prioritize safety and consult with qualified professionals when working with electrical systems.